Further study of the respiratory system. How could we show that we exhale carbon dioxide? Carbon dioxide reacts with a solution of calcium hydroxide to form calcium carbonate, a precipitate. If we use a straw to exhale into a calcium hydroxide solution, it will turn milky. Check out the link below to see this experiment in action. Carbon dioxide reacts with water to form carbonic acid, which has an acidic pH. If we exhale through a straw into water and measure the pH before and after, we will see that the pH drops, evidence that we have exhaled CO2 into the water. How can we see that water vapor is in the air that we exhale? If you chill a small mirror or piece of glass and then exhale on it, the water vapor in your breath will be chilled by the glass and condense on it. How can we measure respiratory rate? The respiratory rate is the number of breaths taken in 1 minute. In the classroom, we can count the number of full breath cycles, both inhalation and exhalation, in 1 minute. The normal rate for adults is 12 to 20 breaths per minute. How can we make a model of a lung? We can make a model of a lung using a plastic water bottle and 2 balloons. This model demonstrates how negative pressure causes lungs to expand and positive pressure causes lungs to get smaller. The upper balloon represents a lung and the lower balloon represents the diaphragm. What parts of this model accurately represent how lungs work? What are the limitations of this model? How can we measure vital lung capacity? Total lung capacity, or TLC, is the total volume of air in the lungs after 1 maximal effort inhalation. In adults, the average lung capacity is 4.5 to 6 liters. In a typical breath cycle, we inhale and exhale only 0.5 to 0.7 liters. This is our tidal volume. Vital lung capacity is the measure of how much our lungs can take in and push out with maximal effort. If you inhale as much as you can and then exhale as much as you can, the amount of air expelled is your vital lung capacity. We cannot exhale all of the air in our lungs, so there's always some air reserved to maintain the shape of the airways, approximately 1 liter. So if your TLC is 4.5 liters, your VLC might be 3.5 liters. The diagram below summarizes lung capacity. Note that there's always at least 15 ml per kilogram of air in the lungs, no matter how hard you breathe out. In medical settings, measures of lung capacity are carried out with spirometers, tools that measure volume of air held in the lungs, inhaled and exhaled. We can measure our vital lung capacity in the classroom with a simple tool that teachers called a lungometer.